Welcome back to the MemSQL Developer Livestream. Last week we did a lot with unit testing and we created a lot of mocks. Today we're going to take that a step further and we're going to build out the unit tests associated with the product list screen. We're also going to build integration test, an end-to-end test that flexes from the API all the way to the database and back. So let's dig in. Here's where we left off last week. We have our product. We refactored it a little bit to separate out this function, and we took a look at all of the endpoints. This one ends here, this one ends here, and this one ends here, so we built out 3 tests. Each test validates one scenario here, so should return a product when found in the database. We have this really nice pattern, arrange, act, assert, where we set up the things that we need to build in our test, then we do the action associated with our test, and ultimately validate that we got the response that we expected. We spent quite some time building out these mocks that create fake data for our interfaces. So for example, we built out this mock request. Now these are all the parameters that we use in the request. They aren't all the parameters, but they're the ones that we care about. Similarly, we created this mock response that faked out all of these methods. Now in the mock response, we did keep track of this state so that we could use that state to validate interesting results. Similarly, we created this mock database that mocked out the query method, taking in whatever we wanted to return and sending that back to the calling code. Now here we have this of type T result. This is a generic in TypeScript, and this allows us to identify the innards in a very generic way. So we say that we have this property that is, where is this property? We have this property and it's of type that thing, but we don't know what thing that is yet. And what that made really effective is here where we said we have a product array that we want to send in. So here's our product array definition, and here's our product array that we want to define. So let's take this further and let's build a similar test for this products method. So products here, we'll see that we have one endpoint. So do we only need one unit test? Well, we actually do have 2 endpoints. One that returns an empty array if we found no results. One that returns the actual results. And we're doing some validation here. It'd be nice to set up a unit test to do that. So let's dig in. New file, nope, not there. New file inside routes, products.spec.ts. And we can probably lift a lot of the code out of product. So let's start there. Now we're no longer testing the product, we're testing the products. And we'll get products by page. So that will be the thing that we're, not there. That will be the thing that we're flexing. It should return the products when found in the database. So this is routes products. Now, our test is going to work a little bit differently. Let's go back into this products method. Now we do still need to make some changes. This will be of type row, row data packet array. That one's the one that always trips me up. Row data packet array. That's what the MySQL promise driver will return. This is of type request. This is of type response. And this is of type connection. Okay, let's yank this method out. This is the get products by page method. So we'll set that in place right here. Get products by page async function. Let's export that and make it a function. That's pretty cool. Now we do need to pull in some types here. Import express. VS Code's going to help us. That's perfect. Ooh. Export async. Nope, it's not helping yet. Okay, so let's pull some things in. Import request and response from express. Import connection from MySQL promise. And row data packet. Now is VS Code going to help? Yep. That will come in from MySQL promise as well. Oh, MySQL 2 promise. Okay, so now that we've separated that out, now we can come back in here and start to dial out our test. Now we're not going to pass in a product. We'll pass in a products array. Let's say page is 0. Our products array. We've done this trick to say we're not going to define all of the parts of the product. We're only going to define those things that we really care about. So that product code, let's call this one ABC, and this product code we'll call DEF. Now we're not passing in product code, we're passing in page. Ooh, it doesn't like that. Params expects the array to be strings. Okay, we can do that. Let's dial out this page. And now this JSON isn't a product, it's a products. And I'm actually going to set the products first and test the status later. Let's also expect db.state.values 0 to equal page. We want to validate that we typed in the page number correctly. Let's test this out. npm run test. How are we doing on our test? Our original 3 passed. Ooh, this one failed. Okay, so value 0 isn't page. Let's take a look at that. Value 0 isn't page. As we pass this in, we pass in active, page size, and page size times page num. What we're trying to validate is page num, so we're going to need page size. Export const page size equals 20. Okay, page size is 20. In all the places where we define page size here, let's use our new page size. And now here in our test, we can pull in page size. And so we know this is page times page size. And it's also number 2. I'm not thrilled with doing this math here. I would rather be able to validate directly that I've got the page, but I understand. Let's run our test. And it succeeded. That's perfect. Okay, so our next test, we want to validate that if we pass null back from, or undefined, back from the database, that will return an empty array. Return empty array when database returns undefined. Okay, so our products is still a product array, but now it's going to be empty. Let's pass in page 100. Okay. So now we expect our JSON not to be products, but rather to be an empty array. Empty. Or we can go match products. Well, in this case, we don't want it to be the exact object that we have here, but rather to equal products. Cool. So if here is passed in undefined, empty. We'll change this to of type undefined. Then we should expect this JSON to be not undefined, to be this empty array. That's cool. Let's test out this. npm run test. That worked. Now our third test is about validating those input parameters. What if we pass an invalid page, or what if we pass no page? Let's try to do that. Let's say no page, and we'll pass in some data. That's not important right now. Validating the return data, that's also not really important. What we want to validate is that the page number here is page 0. So we want this to be page 0. We're passing in no page parameter. And this is now a product array. Okay. Should return page 0 when passing invalid page number. That is perfect. npm run test, and let's take a look at what we see. It failed. What we got was not a number. Let's take a look through our code a little bit. So we're parsing that as a number, and then we're using it in the calculation, but we're not taking any measures if it's wrong. If page num is less than 0, or is not a number, page num, we should set page num to be 0. This is no longer a constant. Now we could also set up a max page, if you ask for pages bigger than 1,000, but nah. Okay, so we've got that test. We've validated our code works, we've improved our code, npm run test. Thank you, test, for helping us find problems in our code straight away. How did this go? That was great. Now we also have this validation of the active parameter. Let's do a test about that as well. Should return active when not passed active flag. So this is a query, and we're going to pass in no query. And we expect active. Where does active show up? Active is the first thing. We expect that to be true. So 0 should equal active, and active is true. So no active parameter should return to us a true value. Let's do that test. npm run test. Great, all of our tests pass. Now this was excellent. We got to use mocks. We got to use mocks and fake out the data that wasn't important so that we could focus on the things that we really did need to focus on. We built out the test to be able to validate each piece of our thing. But now, how does that work in context? We need to build up these units into one full thing. We need to do an end-to-end test that will start at the edge of our API, run the request all the way to the database, get data back from the database, and validate that that's what we expect. So let's use Supertest for this. Supertest is a great library for pulling in that kind of end-to-end testing in APIs. Supertest here is, you can pull in Supertest, and then you pass Supertest your Express app, And then you can do request.get to get a response, and then validate that response doing really interesting things. So let's do exactly that. Here in our app, we'll create a new file, app.spec.ts. app.spec.ts, describe. Oh, actually, did I fail this? Nope, it's routes products. App. Well, I'm going to make an end-to-end test, so I'll just call this end-to-end. In time, we may choose to run our end-to-end tests separately from our regular tests so that those things that are slower get only run occasionally, and those things that are faster we can run all the time. We're not going to do that yet. It should get the product detail, product list page. Okay. Now what we want to do is that. So let's say const super test equals, import. Import super test from super test. Let's import our suite under test. Import app init from form. From app. And now we want to do that. Arrange, act, assert. Okay, so const request equals super test app. How do we build our app? Const app equals await app init. Well, why did I do that? Async. Why did I do this, calling this function? Well, what we built in our app is actually this init function. This is perfect for being able to spin up things. We're not returning a singleton. We're returning a function that will build our thing. That's actually really cool. It'll also spin up our database, grabbing all of our details from our .env file here in this env config. So we know that this is going to build up this Express app in a really elegant way. Const response equals request.get API products. Let's grab page 0. We're going to assume that our database has some data in it. Let's await this. And let's expect res.status to equal 200, and let's go grab the results out of it. Const products equals res.body as product array or undefined. Expect products dot length. How many products do we have in our database? I don't know. And we shouldn't need to know. We know that it's going to be 1 or greater because we initialized our database with that. And we know it's going to be our max page size or less. So let's set up the test that way. To be greater than or equal to 1. And to be less than or equal to page size. That's cool. We grabbed page size from products. Let's also pull in product. Now it's actually not in product, it's in types product. And this isn't from app, but rather app. That way. Okay, we're doing pretty good. We've got our test. It's going to go hit our API. We're going to get our response, validate that we got a 200, cast the result as a product array, and then go dig into it to see if we've got what we expect. Let's run our test. npm run test. it passed, it did what it expected, but a worker process has failed to exit gracefully and has been force exited. This is likely caused by tests leaking due to improper teardown. Ooh, improper teardown. Here in our app, we spin up a connection, but we never close that connection. So of course, our test finishes, our database is still running. Let's solve that. Before each, now this will get run at the beginning of every test. And there's a similar after each that will get run at the end of every test. So we want to go grab const db equals app.locals.db. Let me validate that's the path. Is it locals or is it local? Yep, app.locals.db. Let's go grab that app. If db. Now, how do we close that connection? Coming off to the MySQL 2 docs, there are two ways to end a connection. You can call the end method or you can call the destroy method. The end is a little bit gentler, so let's call that. Await db.end. Now we are going to check to see if this app exists, because if it fails before we get this app created or before all of the details get set, then this database might be empty. This is async. Async. So now we need to move this out here. Well, we don't want to initialize it here. We want to initialize it as we start up each app. So let's do that here. And now to properly type this, we'll say this is of type express. Thank you, VS Code, for being able to find it. Oh, are you going to not find it? Import express from express. Okay. Oh, how did we do that before? Ah, yes, let. Let. We're going to set it later. Okay, so we've got our Express app ready to go. Now, I did hit an error where it would give me this cannot read property address of undefined. And their solution here in this post is not to pass the Express app to Supertest, but rather to pass an HTTP listener. Here in our index.cs, we are creating this HTTP listener. And so let's do that. Let's go create our HTTP listener. Let server, and this is of type server. We'll pull that in from HTTP as well. And now we'll say server equals create server app. Now we've got this server object. We can pass server into our Supertest. And now we're ready to go. We've got a test. npm run test. It's running our unit tests. It's also running our integration test. So it'll start at the front end of the API, actually make a web request, make a connection to our database, and pull back data out of our database. Cannot read property address of undefined. Ugh. It looks like we hit that timeout. We're not able to run our test as fast as we need to. Let's add some more time in here. Wait longer. npm run test. Yes, that succeeded. That was great. Well, we're hitting our product list page. Let's create another test that will hit our product detail page. Now, we could create a completely separate test, it and do all the things, but I would really like to use the first product returned here. I know that there's at least one. So const product code equals products 0. And now let's build our second test based on that detail. So should get the product list page and the product detail for the first product. Test 1, product list. Test 2, product detail. Now we could do wacky things with creating dependencies between tests and keeping variables, but I find this a little bit more legible. Okay, so we're going to go grab that product code. We don't need to create a request anymore. We do need to create a response, but this is product and product code. We expect the response to be a 200. This is not a product array, but rather a product, const product. We expect product dot product code to be, or to equal rather, the product code. And we're ready to go. Well, kind of. This we'll have to say let now instead of const. And it's saying, hey, this could be null. Well, we validated that it isn't null here, or rather undefined, but TypeScript doesn't know anything about how expect works. So we'll say if products throw new error, blank product list from product list page. I flipped the sign. If not products, and now TypeScript is happy. We've got all of the things. npm run test. We got a 404 asking for that product. Did we mess up that URL? API product code? I don't think so. Let's go look. App.spec. Ah, yes. It's not the product, it's the product code. We could definitely use TypeScript debugging, and we set this up earlier to be able to dig into all of the pieces. But we were able to quickly flip in to just look at the one piece that we needed. npm run test, and we should get all green tests. So now we are able to flex our API in all of the ways. One of the interesting questions here is, how do I do code coverage associated with this? Well, inside the jest.config.js is details around figuring out code coverage. So collect coverage. Collect coverage is true, and collect coverage from, I want to look at source files and only TypeScript files. So I want to grab all of my TypeScript files inside my source folder. I don't want to grab any JavaScript files. I don't want to grab any non-TypeScript files. npm run test. And now it's going to not only run all of the tests, but harvest all of the code coverage metrics around this. Now the bummer part is code coverage is a really easy metric to measure, but it doesn't tell us that we've grabbed all of the scenarios. It merely tells us that we've run code on all the lines. So this can be a good indication. Like in this case, we didn't test index.ts at all. That's a good indication that we may have some concerns here. But index.ts inside the routes, or this products.ts line 17, it may not make sense to go after all of the pieces. In this case, I think it's showing us that we didn't test this code. We only tested this code, or vice versa. But chasing 100% code coverage, I tend to avoid that. But now we've got code coverage in place, so that's pretty cool. Now that we have our tests in place, let's pop open the Docker file and make sure that we run our tests on every build. Now we know by the time we're building our production runtime container, we know that our tests have passed. That's perfect. So we were able to look at unit testing the product list page rather, mirroring our experience with the product detail page, and we also built a integration test, an end-to-end test that was able to validate from the front of our API all the way through our database and all the way back. We added code coverage, and we made sure that our Docker file ran all of our tests before it built the production container. Next week, we're going to look at doing unit testing in our SPA app. So we'll get to look at unit testing components. That'll be really fun. Join us next week at 11 Pacific for the MemSQL Developer Livestream.